Okay, now let's do an example. We have this shape, okay, and this is the R, the domain of the integration, as I said earlier. We are gonna do double integration. You can do in terms of dx dy or in terms of dy dx. Okay, then this is the equation, and the first thing we need to do is to see which one is better. Yeah, never mind. I'll just show you. So apparently, if you were to use dx dy first, so you integrate in this dx manner, so it's a vertical one by one. The curvature is it's always the same, right? It's this equation. But now if you were to take dy, the curvature is also the same because it didn't change much. It didn't suddenly come out like that, right? The equation is a little different. So apparently this is how it goes. It's a little hard to grasp because it requires certain experience induced into you to realize certain things, which I also have a little experience, so I make things complicated sometimes. But however, you can do, because this is a non-complicated shape, so you can do in terms of dx dy or dy dx is also okay. So now the problem is, right, we have to set in terms of, apparently I already deal with all these things. Now we're trying to deal with certain limits. The shapes thing, I hope you really understand what I mean, because the key thing I just now I realize, maybe I just redraw. Okay, the key thing is very important. Okay, let's say we have maybe it's not good, the shape. Or maybe I use the shape. Okay, now I use the shape. So apparently one key thing is to see, okay, the is this thing, and okay, is maybe I use the red pen. Is this point and this point always having the same slope? If either one of the point has a sudden change of a different form of a slope, then that line is that form of inner integration, meaning let's say this is dx dy, okay, this portion is the inner integration, and whereas this outside one is the outer one. So the inner one normally is the first thing you need to do is to deal with the inner one, and then so you can see that if you were to do in this manner, eventually when you reach here, you have a certain you require another equation for this slope, okay, right? Because this is going down slope, this is going up slope. I hope you get what I mean. Or however, if you were to look at this point, let's say now as you can see, this one will be a dy, okay. Now we deal with a dx. So apparently we have a dx. Maybe the dx is pretty simple. You can see that the slope itself, there's not much things to account for because you go like that, and then there's nothing over here, and like that. So apparently I think this also may require another equation, I think, or maybe not. If you were to take this integration, then x is, it should be the case. It should be that at this, since this two thing follows this slope, you don't care anything. You will have a equation that accounts for the slope, okay, for this total slope. So you just sub in the thing, and then you calculate and then you go in terms of dx. So in this case, dx is more preferred because there is not much change. There is throughout the whole thing there is constant slope. There is no change in a sudden abrupt slope. But however, dy, when you reach here, you have a sudden change. You have a sudden change of the slope, a new type of slope. The one thing you may also ask that why dx this point same, but how about this point? This is the only concern that I also been thinking of. So apparently, I think unless you take limits, unless your dx is also here, unless you take dx in terms of maybe this is 5 and this is 0, and then the limits you take it to a certain point, then whatever lah. Anyway, you just take it like that. You just accept it. This is what they always say. So this is so far how I realize lah, how things are being dealt with. And then yeah, let's go back to this question. Okay, so apparently we can do in terms of dx dy or dy dx, no problem. Okay, and then one key thing is that I also got doubts is that if you integrate in terms of dx, right, you have to the integration, isn't it should be in terms of y. I think this should be in terms of x equals to, okay, see x equals to this thing, 1 minus y squared over 4 instead of x squared minus. I mean it should be this yeah. You see why? Because when you sub this thing into x, right, then it should be y squared. So the outer one will integrate dy. You see? So I think this is surely in terms of x equals to 0 and x to something. Then this is y and y, you know. So this is the point I want to make clear of. I just realized also. So with that, what it means over here, okay, what it means over here is that I take x when it is 0, okay, to a certain point here, okay. So at maybe at this thumb 1, okay, thumb 1, or maybe first strip, okay, first strip of this line. It is from when it is x is 0 to this thing, okay. So you calculate and you get this point over here, and then another. Now we are taking a very small. Just trying. We're not integrating it, but we are trying to show you how this is being worked. You know, so you eventually know how the integration do with things, you know. So apparently this is the first one, this first strip. And then the second strip is maybe, the second strip is over here. And it has a slightly little shorter length. So it's from 0, also using this formula to this thing, right? So apparently this formula will dictate how this thing will eventually move. So eventually you have this so many so many strips until here, and then eventually you'll get 0, and then you eventually get here lah, you know. So this is how in terms of dx how it works. And then for the outer section, is because now you already settle the dx. Now you have to settle the outside one, the y. Okay, so apparently the y you have to sub it into your equation. So imagine if your y is, let's say if your y is 0, then this whole thing is 0, and then you bring it up plus minus 3. Now this is 3, so it should be sorry, this is x, right? So 0, 3, 0. So when y is 0, x is equals to 3, and when x is equals to 0, okay, this thing is 0, this one will be y squared equals to plus minus 2, right? So y is equals to 2. Okay, I hope you get what I mean. So apparently if you integrate x already, then definitely you just integrate the rest of, okay, you just integrate the rest of, which is this, should be y equals to 2 and y equals to 0. Okay, so it should be this manner. And alternatively, you can also use dy dx. So dy dx, now the first thing is to find the equation, and you eventually get y equals to 1 minus x squared square root and 4. Right. And then it's the same thing from 0, your equation is this point, the first strip. The second strip, your equation is at the slightly lower point and slightly lower point. So from 0 to whatever the equation would follow will lead you to, and you'll eventually get this shape. And then this is the dy, and then dx is the same thing. You go in terms of this manner, and then this is because now this is the outer one, so this should be 3 and this should be 0. Okay, this is the very damn easy one. Okay, this is damn easy. When I'm doing it, you see, you can see the flow. But I think this is just to convey the basic ideas of how double integration works. But when it comes to dealing with like really complex shape, like what I show you this one, ta-da! Then you're like, what the fuck, right? How do I do this? You know, first how do I do? I think in terms of dx or dy or dy or dx, you certainly have to break at this point. This is the threshold point, I think. I don't know, I don't know. For you to find out. Okay. And let me see. What other things that I need? Oh, okay. So the next thing is that if you happen that you find this shape already, or happen that if you're given this shape and you ask to find the double integration of this shape, what do? One method is to take this part, one part of it, and then you do in terms of this, and then you times 4 and get back this shape, the double integral value of this whole shape. So yeah, I think so far so good. This is it lah, So another example is this shape lah. Okay, this shape. So if you're taking in terms of dx dy, this whole curvature is the same. Okay, it from certain one. So this is one equation, and this is also one equation. So your limits will be one equation over here, another one equation that deals with this thing, another equation that deals with this thing. Okay, and then dy is simply just the limits between this point and this point, I think. But anyway, but if it's in terms of dy first as the inner one, this is the first thing. The first limit will be this one, right? Which is a constant 0, and then this thing follows a curvature until here. Then when we reaches here, this one continues to use the same curvature, but this one the curvature changes already. So you need another term, maybe plus, then another double integral, then you know what I mean. So apparently this is the general concept I want to convey to you. Okay, this is the concept I want to convey to you. And so what are the limitations that I have learned is that what if you know these two limits, but how you know these two limits? The outer, since he concentrated on the inner one, then what about outer? Okay, the outer one, let's say you already found this shape already, then the outer one you just simply from integrate 2 to 0. That's it. I have no idea, man. If you integrate dx first, you integrate all these things, and then you integrate in terms of dy 2, 0. You're integrating this thing, right? He didn't explain the meaning over here, but yeah, let's just take it first. I'll just end here. Okay, I'll just end here and we'll continue. So far so good. We have already done all these things. Okay, then later I'll talk about the vectors. Should be quite fast. And then the Fourier series. So see you in the next video.